All right, so don't know how far you got to this with the p distance, but I want to go over what numbers ended up in here. So here's how I counted these. And I think you guys can see my answers now. But you counted the differences. The one tricky one is this one, which is B and D, because B and D only have up to 9 nucleotides that you're comparing. So they have two differences over 9. And then the matrix on the bottom I have the same as these. It's just that it makes it easier because I don't know, is it 4 tenths greater or lower than 2 9ths? So then we make them in as decimal points, so that way you can see. So let's, I'm going to switch cameras now so that you can see on my sheet here. Let's see. Yeah. So do you see my sheet here? Don't know if that's what you're seeing now, but yeah. Oh, good. So here are the answers. I should probably have kept all these guys also in decimal, but as you saw, 6 tenths, those I can, I'm so good at math. I figured that this is 0.6, 0.4, 0.6, 0.5, 0.5. Okay, 0.22, that one. I was like, I better cheat here. So let's see. There you go. Okay, so once you have this, then what you do is you find the two most closely related, because remember that when we're building the tree, we're going from the two most close related. Remember how we are branching out? Okay, come on, camera, don't fall. So we are branching out. So we'll find in this matrix, then what are the two most closely related? So then you could go like, okay, is it the highest number or the lowest number? That's something you want to know. So let's see. Yeah, B and D, good job. Right, it is the lowest number because this table is showing you the distances. So the smallest distances, the smallest distance means that they are the more closely related. So what we're going to do is over here, I'm going to write down the entities that I merged because I'm going to make a tree. So let's see, over here. I make my tree over here, which you guys are right. Okay, pretend this is straight. And my two most closely related are B and D. And I could write D and B, doesn't matter. This length here, no, the edge or branch length is actually that number there, the 0.22. That's the distance between B and D. But so this is 0.22 is this plus this. So remember that doesn't matter. I could have made it more spaced, doesn't matter. But this plus this, and the unweighed pair, that means that I am just going to take this, right? So each of these guys is 0.21 or 0.11. Good. I was checking pay attention. All right, so that is 0.11. That's the length of this branch and this branch. When we do fancier things, then you don't just take that distance and split in two. But in here, since it's unweighed, then you're just going to say, oh, sure, we'll split the difference. So now I want to know who's the next one that's coming in. And at this point, I don't know. So I have to redraw this matrix here. I'm going to do this first step, and then you'll see where I'm going with this. And then you can work on this whenever, if it's not sunny this weekend, bad weather, or you can't sleep, then you grab this paper Yeah, you can print that and do it, or just copy over. All right, so the way we do it is A. Now, I put B and D here together. Now they are married. They don't exist as separate people. Their opinions don't matter. They share everything. So B plus D, and then C. So we say that B and D are one entity now because they are one node. We're merging them. So then I'll have A, B plus D, and then C. And I could compare A against A is 0, B and B is 0, C and C is 0. That doesn't really inform me much. But I want us to fill out these parts. And you're like, interesting. So let's do the easy part first, which is A and C. What's the distance between A and C? Oh, that's easy. The distance between A and C hasn't changed on my new matrix. A and C is 0.4 still, because it comes from here. Now, what changes is this. What's the distance between A and BD? Okay, the distance between A and BD is the average between the distance of A and B and A and D. So A and B is 0.6, so I'm going to put here 0.6 plus A and D is 0.6. That's coincidental, not by design, divided by 2. Okay, I'm going to end up with 0.6. That's the answer for that one. How about the distance of C and B and D? Is the average between C and B. Okay, C and B, which is half, plus C and D half. Oh, how convenient. Divided by 2, that's going to be half. Okay, so to end this, and then we'll pick up from here, what you are going to do is, all right, what is this other matrix for? And what's the next letter that will come here? Suspense. It's going to be either A or C. And what letter goes in there, it depends on the lowest distance here. Then you find the lowest distance, read out the matrix so that you can tell what's the last distance here on the tree.